Today we're going to look at elimination by multiplying both equations by a value. If we take a look at these two equations, we can see that in the x variable, we have a 2 and a 5. There's no way to change a 2 into a 5, and no way to change a 5 into a 2. If we look at the y variable, we have a 3 and a 7. There's no way to change a 3 into a 7, and no way to change a 7 into a 3. So what we're going to do is multiply both equations by a particular value in order to eliminate one of the variables. So we're going to pick x, just because I want to pick x. No other good reason than that. You can pick either value, x or y. So we're going to look for a value we can multiply 2 by, and then a different value we can multiply 5 by to make them both into the same number. Conveniently, if we multiply the 2 by 5, and we multiply the 5 by 2, we're going to get 10. Again, make sure you rewrite both equations. Don't just kind of scribble out. Make sure you rewrite the both before you subtract. So now we're ready to subtract. So when we take 10x minus 10x, we get 0. 15y minus 14y is just y. And 50 minus 4 is 46. So we get that y is 46. Now we're ready to plug back in and find x. Why don't you try that? Plug into 5x plus 7y equals 2 to find x. Pause the video. Okay, hopefully you found out that x was negative 64. So now we know the intersection. It's negative 64, comma 46. Please pause the video and copy this into your notes.
Okay, now it's your turn. Solve the following system of equations using elimination. However, I want you to make sure that you use the y variable that you eliminate. So that way we're eliminating the same thing when we check the solution. So again, eliminate the y variable. Please pause the video and work on the problem. Here's the solution. What we decided to do is multiply the top equation by 5 and the bottom equation by 3 in order to make the y coefficients both 15. Then by subtracting both equations, we got 29x equals 16. Solving for x, we got 16 over 29. And again, you could use this as a decimal. Then we substituted the 16 over 29 back into one of the two original equations. I chose the 2x plus 5y equals 3. By doing the algebra there, I found out that y was equal to 11 over 29. Therefore, our intersection point is 16 over 29, comma 11 over 29. Please pause the video, copy this into your notes. Here's another problem. Again, eliminate the variable y from the system of equations. Also take note that there's a negative sign here. So we can probably just add the two equations once we've made the coefficients the same value. Please pause the video and work out the solution. Here's the solution. Please pause the video and copy this into your notes.